Hi class, we have the third class for limit of a function. We want to find the limit of these two functions. All right, the first one says the limit of x to the power 4 minus 1 over x squared minus 1 as x approaches 1. Okay, this one is a rational function. The previous two videos, I explained everything about rational functions. So I advise for every video, if you are seeing this for the first time and you are interested in the class, check for lesson 1 and lesson 2, then you'll be able to flow to this level. All right. Once we have a rational function wherein the numerator contains x as well as this one contains this variable x, that means you test first and see if by direct substitution the denominator will give us 0 or not. Now, if x approaches 1 and we assume that x is 1, then we can say 1 squared minus 1. 1 squared is 1, and that 1 minus 1 is 0. So this one messed the whole thing because we don't want the denominator to be 0. So once the denominator will give us 0 by direct substitution, we need to do something first with the function given, which is x to the fourth power minus 1 over x squared minus 1. Okay, remember 1 can accept any power and it will still be 1. 1 raised to any negative value is 1. 1 raised to any number is 1. So in that case, we say x to the fourth power minus, or we can say, since the denominator we have a square, what do we say? We can say x to the power 2 all squared minus 1 squared. 1 can accept any power over x squared minus 1. So now this is the square we recognize for what we want to do. That is difference of two squares. Difference of two squares. So what do we do here now? For difference of two squares, we usually have two brackets. The first base here, x squared minus the second base. There we go again. The first base plus the second base over x squared minus 1. I hope it is clear. So x squared plus 1, oh sorry, not this one. X squared minus 1, x squared minus 1. We are left with x squared plus 1. So now we can assume this one and we say as x approaches 1. What happens when x approaches 1? So we replace x with 1. So this x is now 1 squared plus 1. 1 squared is 1. 1 plus 1 is 2. So the second one, the limit of x minus 9 over root x minus 3 as x approaches 9. The same thing applies here. This one is a rational function. Why? Because both the numerator and denominator contain what? The variable x. So the first thing we do, substitute this one in the denominator and see if the result will be 0 or not. If it is not 0, no problem. That is always what we want. If it is 0, then we need to simplify the function first. So if x is 9, assumed to be 9, then it will be square root of, this will become square root of 9 minus 3. Square root of 9 is 3. 3 minus 3 is 0. So this tells us that by direct substitution, the denominator will later become 0, which we don't want. So to avoid that, we simplify first the fraction, the function. So now we say x minus 9 over root x minus 3. So what exactly do we do to to simplify this? Yeah, so what do we do here is the denominator is what? It's a surd expression. So let's try to rationalize the denominator. So rationalizing the denominator simply means we multiply both the numerator and the denominator by the conjugate of this one. So the conjugate of this is root x plus 3, root x plus 3. So now this multiplies this. That is x minus 9 root x plus 3. Whenever a surd expression multiplies its conjugate, what do? The first multiplies the first. Root x times root x is x. Always say minus. Always say minus. 3 times 3 is 9. These are the same. These are the same. The signs are different. That tells you that this is the conjugate of this, or this is the conjugate of this. Multiplying them, you don't need to waste your time. The first multiplies the first, you take your minus. The second multiplies the second. I hope it is clear. So I don't want you to expand this because you know you are going to substitute later. Expansion will lead to more steps and wasting more time. So the fact that this is what we are, oh, sorry, here is 3. Okay, 3 times 3 is 9 now. Okay, so we don't need to expand because this is already the same as this one. So we are left with root x plus 3. So now as x approaches 9, wherever we see x, what do we write? We write 9. So this is root x, which is now 9 plus 3. Root x is 3 plus 3, that is 6. So I want you to try this and tell me what you have in the comment section. Thank you for watching. Don't forget to follow, like, share, and comment. Also subscribe to the YouTube channel. See you in my next video.